Hello, everyone. Welcome to our 45th, maybe, virtual jug session. That sounds quite high, actually. 45 sessions, doesn't it? Wow. Okay, cool. So maybe our 45th session. And today, joining us, as usual, we have Oleg. How are you doing, Oleg?
Hi, I'm great. Really excited to be here as always. And like just yesterday, we got back from DevOps Marathon, DevOps UK and DevOps Poland, and that was a lovely conference. We had a community booth at DevOps UK where we talked to loads of people about Rebel Labs, about the virtual jug, and we got great feedback. So thanks, you guys. You are listening to us. You are watching us, and we really appreciate that. That was fantastic.
Yeah, it was really good, actually. We've been on the road about 3 weeks now, so it's nice to be home. We did Geek Out Estonia, and we did DevOps UK, which is where we got these awesome, funky banners from. We had a community stall there, as Oleg says. And thanks everyone for popping up and saying, hey, thanks for the virtual jug. It's really cool. We really appreciate that kind of stuff. So thanks for that. And yeah, we were at DevOps Poland this week, so we just got back yesterday. So it's good to start with a VJug again. So Oliver, how are you doing, Mr. Oliver Gierke?
I am fine.
Yeah,
Thanks.
Gierke?
Gierke, that's just totally fine. Don't worry too much about it.
Awesome. And where are you joining us from today, Oliver?
I'm in Dresden, Germany. So, what is it, like GMT +1 or something, or +2 these days?
Yeah, +1. So we have a plus. We have a. Oh no, I think it's +2 these days. Yeah. It's,
daylight savings or non-daylight savings, whatever.
Yeah. Well, welcome. This is your first virtual jug session, and for those of you who haven't met Oliver before, Oliver works for Pivotal, and he's been working for Pivotal for about 5 years now. Currently working as the project lead for Spring Data, so very, very well placed to talk to us today about Spring Data. Let me just share my screen very briefly. Here we go, and hopefully, can you see my screen?
It's still black. No. Oh yeah.
There
we
go.
go.
There we go. Perfect. So yeah, this is. Actually, let me just get rid of that. Hide. There we go. Right. So yeah, state-of-the-art data access with Spring Data. If you want to follow Oliver Gierke on Twitter, please follow @Oliver Gierke. Literally just like that. No underscores. No nothing. I'll paste that link into IRC, or perhaps Oleg could do that very quickly now. So the virtual jug is sponsored by Zero Turnaround. Just briefly introduce them. They create revolutionary developer tools. The two which are most well known are JRebel and XRebel. JRebel allows you to reload your code changes instantly for Java applications, Scala applications, Groovy applications, and so forth. XRebel is a new lightweight Java profiler, so feel free to go to zeroturnaround.com, and you can download trial versions of both of those tools for 2 weeks for free, and they're full trial versions. If you wanted to ask Oliver any questions during the session, please do so via IRC. You have the hash virtualjug room on Freenode. And please do share the group and session on Twitter and all your other social networks. Also, please follow us on Twitter @virtualjug. Please send any feedback directly to that handle or directly to me if you'd like. I'm @sjmaple. So without further ado, let's hand over straight to Oliver. Oliver's going to be sharing a few slides, and then we're going to jump into some demos. So looking forward to watching that. So Oliver, straight over to you.
Should I start the screen share then?
Go for it.
Where is it? There we go. Screen share. And there's the screen. You see that?
Yeah, that's good.
And yeah, so welcome everybody. It's a bit strange to present to an audience that's not approachable at all, right? So usually when I'm at conferences, I at least see the people that I talk to. But yeah, the topic today is data access with Spring Data, and as Simon already mentioned, I'm leading the Spring Data project at Pivotal, For those of you who don't know, Pivotal is basically the company behind the Spring Framework. So we're employing almost all of the committers of the Spring Framework and the ecosystem projects. And I'm working on the data stuff. There's a couple of projects and a couple of team members. Actually, I'm of course not working on it alone. Thomas, one of my my colleagues, is in the IRC chat and will help out with questions. Interestingly, Dresden, as Simon mentioned it before, is the Spring Data capital of the world, because there's no other city in the world that more than one team member actually lives in. And by accident, Michael Hunger from Neo4j is actually living in Dresden as well, so we sometimes hook up here and work together. But yeah, what I want to do now in the next like 50 to 60 minutes is basically give you an overview about the project and contextualize it in the first place. So basically, where does it fit in, like the entire Spring ecosystem and even more the Java ecosystem, and then show you a few examples and a few code snippets, and to see how that actually works and get you going. All right, so the topic is data access in or state-of-the-art data access. So what does data access actually mean, and what does it mean in the Java context here? The primary way to like work with databases in the Java world is through APIs, of course, right? So that's what we usually do. And with a plain JDK or a plain Java runtime, and also with a plain JavaEE container, you basically get a few different kinds of APIs that you can work with. As you can see, there's some on the what is it, the y-axis, there's some kind of abstraction, and on the x-axis I have like the different technologies that you might want to interact with. So the first thing you can have is basically JDBC, right? So for relational databases, you have, JDBC is part of the Java SE distribution even. It's supported on JavaEE platforms, and there are even a few libraries out there that build on top of JDBC and provide a bit more convenient access to it. Like you have Juke, for example, or Curry DSL is another one that we're going to see later too. But yeah, it's basically raw database access. You access the data with creating a connection, executing statements, and then mapping the result sets onto your Java objects, probably by hand, right? This is basically a layer where you manually have to map the data that you get back from the database back to your Java objects. On top of that, there's a standard called JPA, Java Persistence API, that actually goes a step further and has standardized a lot of OR mappers I think since JavaEE 5, that is, I guess. So there's a concept of an entity manager, and where you can just which you can hand Java objects to, and it will automatically map those onto relational database, and which you of course can customize, and then store data, query data, what have you, right? So the higher level of abstraction basically makes things more convenient from a developer's point of view, because you can just hand the object, the Java object you have, your customer, your user, what have you, to the API, and it will automatically get persisted. And there's also an API to define queries in a programmatic way, so you don't have to deal with SQL, which some people think is a bug, other people think is a feature. Of course, with the rising level of abstraction, there's always things get more comfortable, but you still have to know what you're actually doing and what the level underneath is actually doing, right? So that's the space for the relational side of things. And in the last couple of years, the space of non-relational, which actually should be infinitely larger than the relational one, right, has emerged, and quite a few different databases have emerged. And there's basically like things like CouchDB, MongoDB, or Neo4j, basically non-relational stores. And most of them actually have provided or have Java APIs, Java drivers available that fundamentally all expose an API that's sort of on the level of the JDBC API. So what you have to do here is, let's say, take the MongoDB driver, for example. It basically offers you a concept called the DB object, which is basically a map, and you can actually store those, and you have to take care of that of the mapping of your domain objects to the store specifics as well, right? The same applies to Neo4j and Redis or Solr/Elasticsearch, like search-related store technologies. But you can see there's a certain diversity here. I mean, that's if a group of technology basically defines itself by what they are not, right? So non-relational databases. It's basically clear that there's a huge diversity, and all these APIs are quite different, right? So you basically have to, if you're working with MongoDB, that sort of works quite differently than what you get with Neo4j. So these APIs can be used in a plain Java SE context, in a JavaEE context, and that's just fine, right? So what does the Spring framework actually bring to the party here? The core framework basically supports the very same things. I mean, there's no dedicated support in Spring framework for MongoDB or something, but you can use it alongside the framework, right? So just as you could use MongoDB from a plain JavaEE application server, you can do so with the Spring framework-based application. However, the framework adds a few bells and whistles around the relational APIs. So for the JDBC, we actually have the abstractions of JDBC template, which takes care of solving a few like convenience problems, like always closing resources. Also, resource management is a very classical topic of these templates. It also translates JDBC exceptions so that the client code is does not depend on the actual database exception, right? Whether it's a MySQL database or an Oracle database. And JDBC template has become like a ubiquitous class or even library. You don't actually have to use Spring Framework as a container to use the Spring Framework JDBC support. You could just go ahead and use it like you would use like Google Guava or something, just as a library. Wrap your data source with it, and then go ahead and get quite a lot of convenience features, like very succinct row mappers and whatnot. The very same, I mean, sort of the same concept applies to JPA. The additional support here is basically in being able to configure an entity manager in the context of the Spring framework, and we apply some tiny defaulting. For example, you don't necessarily have to use a persistence XML with Spring Framework's JPA support. We can just scan the class path for JPA entities. So there's a few convenience things on top of the plain standard. So the Spring Data project basically builds on top of all these things. It's not as massive as it might look like here. What I wanted to get across with that slide is basically that we build on top of JPA, that we build on top of the Java drivers for the mentioned stores here, and add functionality on top of it that even abstracts things more and provides you a more high-level API. And basically the area on the height of the JPA box, but on the non-relational side of things is that we add object to store mapping for the non-relational databases. So with Spring Data, you're able to just take your person object and store it into MongoDB and get an annotation-based mapping kind of mechanism, just as you are used with JPA. Right, and the very top layer, the one that's crossing all of the relational and the non-relational stores, is the repository abstraction, and that's what I'm going to show you in a bit. Right. So,
quick question from
yeah.
PM771. Actually, Thomas has literally just put an answer in, but I'll ask anyway. Where does Hadoop fit in the diagram?
It's sort of, I mean, I could have mentioned it in the non-relational space here, but as you can see here, I've restricted myself to non-relational stores that are data stores, like plain data stores, basically. Hadoop is kind of a different beast. There is a Spring Data for Hadoop module, but it's kind of a different beast in the terms of that it's not only a store, because there's like the distributed file system and Hive and Pig and all of the ecosystem things. So that's why we basically separated it out from the core Spring Data modules a bit, because it's basically much more extensive and integrates with other things that are not really like not only just the store that you just access.
Cool. That was more or less what Thomas also said.
Yeah. All right. So what kind of modules does Spring Data currently have? So it's not a single project that you say that has an individual release. Like there's no Spring Data 1.2 or something. There's a set of modules, and the core modules that we as a team at Pivotal maintain is just the one that I just show here. There's a core module that basically all stores, also the community modules that I'll show you in a second, are based upon, and that allows us to, I mean, of course, not to repeat ourselves in the individual store module implementations, but also add functionality to all of the store modules by just like introducing new stuff inside the core module. I have a few examples of that later on, but there's quite a lot of it in there, and I mean, then there's the JPA module that you're gonna see in a bit, the MongoDB module, Neo, Solar, Gemfire is a distributed, is a data grid actually, distributed data store. There is the Redis module for Redis. We're going to introduce with the upcoming release a key value module, which sort of has the same purpose as the core module, but is targeting key value stores in general. So what we're shipping with the upcoming release is basically a mechanism to define map-based repositories, just like concurrent hash map-based, for testing purposes mostly, but also APIs for modules like Gemfire and Redis to actually build upon. But they're going to be migrated onto the key value module in the upcoming releases, so in a sort of step-by-step basis, but that's going on there. And the odd one out here is basically the REST module, but I'll show you that in a bit as well, because that's some kind of the most top layer project. There is the repository abstraction that you're going to see in a bit is used with the REST module to basically provide REST resources for your Spring Data managed domain types automatically, and you're going to see that in a bit. So that basically builds on top of all the other store-specific modules. Besides the modules that we maintain as a team, there's also a few community modules. So basically, other database vendors or even just Spring Data users that had to work with a different store that wasn't supported in the first place, and basically created a Spring Data community module built on top of the core module for the store they want to work with. So Michael Mitschinger from Couchbase is working on the Couchbase module. There's a few guys at the Biomed Central publisher that build the Elasticsearch module, and a few guys from actually independent consultants that had to work with Cassandra build the Spring Data Cassandra module. And yeah, they are maintained not by us, but by these guys. And there's even a few more coming up and incubating. There's a database technology called Aerospike that has a module baking, and a few others. To be honest, I almost lost a bit of track of where these modules start to pop up. The ones I've listed here are included in our so-called release train. So while these modules develop on an individual pace to some degree, especially with the community modules, we orchestrate the releases and basically have a release train that we name after computer scientists. So the currently maintained, mostly maintained, main release train is the Fowler release train, so named after Martin Fowler. The upcoming one will be Gosling, and those include these modules and can be just consumed easily. All right. What does a Spring Data module look like? What does it actually consist of, and what is it structured like? The most fundamental thing that we built, or actually build where needed, is the object mapping subsystem in a Spring Data module for JPA, and that's why what probably has become obvious from the graphics before is we don't actually need that, because JPA already implements like an object to store mapping through the persistence provider implementation like Hibernate, Eclipse Link, what have you. But for the MongoDB module, for example, actually has this kind of stuff built in the Neo4j module. Basically, everything that's not JPA has this kind of stuff built in, right? So that allows us to actually take plain Java objects and persist them into the store. On top of that, we built the so-called templates. I already mentioned the JDBC template before, because that's the one that most Spring developers at least are familiar with. There's a lot of other templates in the Spring framework, like the mail template, there's an AMQP template, and what have you. And that actually using the template pattern here is actually a first indicator to the way that the Spring framework and Spring Data especially approaches the aspect of knowledge transfer here, right? So you probably agree that JDBC is a totally different from, let's say, AMQP and mail, right? Or sending mails. So no one would really come or get the idea of trying to abstract that behind a singular API. But if someone has worked with the JDBC template, she basically knows that that the template has basically the responsibility of the template is basically resource management and exception translation, and that's the case for the JDBC template. That's the case for the mail template, and that's also the case for Mongo template and for Neo4j template and all the templates that we actually introduce, right? So they share the same traits, they share the same characteristics, the same responsibilities, but of course they're targeting different technologies. Again, templates are not needed for, or the JPA template actually is not needed, because the exception or the entity manager basically already provides the API that we need for that kind of stuff. But for all the other modules, there's a Redis template, there's a Solr template, and what have you. So yeah, with the templates, what you could do is basically, if you just like have an entity manager API in mind, with the entity manager, you could go ahead and build a repository or a DAO on your own, right? So just like implement like CRUD methods and methods that execute queries, And you can basically do the very same thing with the templates. So you could go ahead and write a repository or DAO that is built on top of MongoDB or Mongo template, and just go ahead and do that. We found out this is very often this is just boilerplate code, especially for CRUD operations. So what we have on top here is a so-called repositories abstraction, or a repositories programming model, which we supply for all the stores where like entity persistence or domain object persistence is actually reasonable. And like domain object persistence basically includes being able to query for that. Modules like Redis that basically are a key value store, so they are just like data in, data out with very limited querying capabilities. Currently don't support the repositories model, but Neo4j does, Couchbase does, all the mainstream stores, so the general purpose data stores modules have the repositories API. So this is basically that's just code, and basically could be used as a library. All of that could be used as a library. So you just add the dependencies to your project and then write some code that actually uses that API. But of course, being a Spring Framework ecosystem project, we have quite a bit of, quite sophisticated Spring container integration. So that basically means there's like configuration integration with both XML if you're still into it, and annotation-based configuration. And that's XML namespaces mostly for the XML side of things. And we also make sure that everything works fine and easy with boot. So there's like boot auto configuration that even reduces the amount of boilerplate configuration to the most minimal thing to do. But as I said, the repositories API, or the repositories and templates and object mapping functionality, is basically just Java APIs. We also go ahead and provide CDI modules for most of the stores, so that you could even go ahead and within your plain JavaEE container take the Spring Data modules. They basically contain a CDI extension. And all of that, what you're going to see in the demo, is also supported in a plain CDI environment. You'll still have to deploy the Spring Framework or some of the Spring Framework jars with your application, because you're using that stuff as a library. But we've decoupled that the core functionality from the Spring container, so that it can be used in CDI environments as well. So yeah, that's basically it. All right. So one thing that I briefly touched on already is like that we're trying to leverage the existing knowledge of Spring users. I mentioned the templates, and try to make it easy to reuse that knowledge if it's applied to other aspects or other areas of persistence. So if you remember, as you've seen there, I mentioned that the NoSQL space is a quite diverse one, and MongoDB works very different compared to the way Neo4j works, and very different to the way Couchbase works, and very different to the way Solr works. So the question comes up is, okay, how can we actually go ahead and build some kind of, is it an API? Should we really build an API that makes it easy for developers to get from one store to the other? And pretty early on in the project, we came up with this mission statement. So the goal of the Spring Data project is basically to provide a familiar and consistent Spring-based programming model while retaining store-specific features and capabilities. So some of the parts should be clear already. So that way, Spring-based is probably obvious. There should be a certain consistency among the individual stores, right? So things should work the same way. But what we don't want to do is, I mean, if you just cut it at a Spring-based programming model and just have a have a full stop there, then you could just try to go ahead and build some kind of Uber API that tries to squash JPA and Mongo and Couchbase and whatnot. But the problematic thing with that is that you basically get to a very tiny common denominator, and you usually use many of the store-specific features, and especially with the NoSQL stores, the stores are actually chosen because of their special features, right? MongoDB has geospatial functionality, for example. So if I want to build, let's say, we will see that in a bit, some kind of geo API where I want to find like restaurants or something, that's just a no-brainer on top of MongoDB. And if we just hide all of that away behind some kind of generic API, that wouldn't really work. So being able to retain the store-specific features is a very, very core aspect, and I hope I can show you that in the second part of the demo, actually. Do we have any questions coming up, Simon, in the meantime? I don't hear anyone talking.
Sorry, I was on mute. Let me just
no problem.
Check. Yeah, we've got a question actually. Thomas has asked answered, but I'll ask anyway, just so that those on the Hangout can, or those watching on the video but not in RC can also get the answers. The repositories, do they create inner classes for the DAO implementations?
No, there's no code generation going on. I can go into the specifics of that when we're looking at them. But there's absolutely no code generation going on here. That's not. There is a bit of in the object mapping layer. We're using some ASM tricks that actually Thomas implemented to increase the performance when reading objects, to instantiate them, to avoid reflection where possible. But the repository interfaces there's no code generation going on for those. It's all proxy based.
Okay, no further questions, so we can dive straight into the demo.
All right. So what you see here is it's just I'm going to reuse the Spring Data JPA example projects, some of them. I have a link to the repository, to the GitHub repo later on in the slides too, and yeah. So in case you want to look this stuff up later on to jump into it in more detail, then you find that in the slides. What I have here is a very, very basic example, or a very basic domain, JPA domain actually. We have customers and addresses. So I'm using a bit of Lombok Kung Fu here, so to generate the accessor methods, but that's actually not part of Spring Data, just to as we just had the question coming up. So a customer just has an ID, first name, last name, and we have an address. The address consists of a street, zip code, and city, right? So just plain properties. There's one join basically here, like a one-to-one relationship with cascades and often removal. So it's basically a composition in the object oriented sense. Yeah, so that's just the domain model we have here, and I've created a bit of code that basically just sets up some instances of that, right? So Dave, Carter, Leroy, two of them with a zip code and one of them with another zip code, so that we have something to work with when querying that stuff. So the way that Spring Data works is that you declare a repository interface. So I mentioned that DAOs or repositories are quite often very boilerplate, but and the goal that we actually have is to reduce the boilerplate to the most minimum amount possible. So I just declare an interface here, right? customer repository. We're going to tweak that in a second. And the test case is now it's basically this just using Spring the Spring test framework that bootstraps a Spring application with that configuration here. In this case, there's a bit of boot magic going on, but I get to that in a second. So we're bootstrapping a Spring container here because that's just the easiest way to get that going. And then we autowire / inject. We could have used that as well. Trying to autowire the repository, and then are going to work with the repository here, like doing customers dot and there's no methods to be called right now, right? So let me just check whether that works, which, if it did, would surprise me. So I'm hoping it fails now. Yeah, there we go. So the test case fails, saying, okay, there's no bean definition. So for those of you not familiar with Spring too much, basically Spring creates instances of classes, or as we will see, for the interface, and is able to hand it to you via dependency injection, and that's what we're doing here, trying to do that, right? So what we see here is that this obviously fails. So the Spring container starts up, sees that we require a customer repository, and we don't get one because there just basically is no component. What the magic that Spring Boot does here is basically auto-detecting that Spring Data JPA is on the class path, and that generally, I mean, Spring Data JPA being on the class path, which means that you're going to write a JPA application. So it's bootstrapping Hibernate for me, and is doing like an entity scanning on that package here, on the package that we are basically now working in, which is example.vjug. And so that, as you see here in the logs, there is Hibernate is bootstrapped, and there are tables basically created for customer and for the address too, right? So Hibernate is bootstrapped, Spring is bootstrapped, but then we fail to inject the customer repository. So how do we actually get that to work in the first place? So the first thing you have to do is basically saying, or turning the customer repository into a Spring Data repository. And you do that by just either extending an interface, a Spring Data specific interface. In my case, I just go ahead and take the repository interface here, which is basically a marker interface that doesn't actually have any functionality, except that it captures the generic, the types that we want to deal with, right? So with that in place, I should be able to run the test and actually inject the customer repository. So you see that worked, right? So the test case is green. So we basically didn't test anything, but that means that the Spring container found our customer repository, and then Spring Data went ahead and was able to create an instance for that customer repository. And it does so by creating a proxy for that interface, and basically putting an interceptor in place that will go ahead and intercept all the calls to the repository that currently we don't have any methods, but it will intercept the calls to the method, to the repository, and then basically decide what to do with these methods calls, right?
Oliver, sorry to interrupt you. There's on the stream, it looks like the code is a little bit blurry, so it might be the resolution, but
yeah,
I think if we change the resolution, it will probably break the Hangout. So I wonder if you could just make the font a little bit bigger. It might be easier to read.
Okay, I can try that. Where is it?
Simon, I think it could be your screen actually.
We're getting some comments in IRC.
Yeah, I know, but like we translate to YouTube your screen, so maybe you could play with your resolution. Not sure how.
No, I don't think it's from mine.
Well, let's see if the code is better now.
Let's try that.
Yeah, it might be just a bit hard to digest, because that's like very let's see if that works, because anyway. All right, so the customer repository. so the first thing that we probably want to do is just persist these domain objects here, right? It's the easiest thing. What I'm going to do is I'm going to change the parent repository to CRUD repository. That's an interface that actually has quite a few. And let me zoom in here. That has sorry for that. That has quite a few very fundamental CRUD methods here, like saving instances, finding an individual instance by ID, and it's basically like CRUD operations. So by extending that parent interface, we get those methods pulled into our repository, right? And which means that we can actually write a test case to call them. Let's try that. So we go ahead and say customers.save. Let's go. We save Dave. Let's go with him, and keep that for reference. And then we go ahead and say assert that customers find one, and we take Dave's ID. Oh no, the reference is ID. Probably get ID, and that should be the reference, right? If we look it up just right after that, and let me try to just execute that thing, and fingers crossed. Oh, that worked. So how did that actually work? I mean, we called methods on the interface, and what happened? We didn't provide any implementation here. The trick is the following: that we're scanning the package here for these interfaces, find the interface, discover it's a Spring Data repository, and as Spring Data JPA kicks in here, it builds a proxy that is backed by I think I've seen it flying through the IRC channel, simple JPA repository that is backed by an instance of that class here that has these methods implemented. So there is a save method that's implemented, and that just does calls persist or merge based on whether the entity is new or not, right? So there is some generically implemented code that we provide, and that allows you to basically execute the CRUD methods. So they have generic names like save and find one. There's nothing domain specific about them. We provide the implementation, and Spring Data JPA basically creates a proxy with that instance in it, and that just handles that method. All right. So what if we want to find all of the instances that actually meet a certain criteria? So where is the customer repository? There we go. So you can go ahead and say I want all customers, and then say find by. And what you see, I'm not sure you can actually see that. But what STS now does, it provides you with code completion about all the properties that the customer object actually has. So in this case, address, right? And I just don't want to find customers based on the address, but on the zip codes of the address. And I can go ahead and add this method here, right? So import lists, fine, and let's see what we actually get to do here. I go ahead and save customers, save, and then I say arrays as list, and say Dave, Carter, and Leroy. So save all of them, and then I go ahead and say assert that customers find by address zip code, and let's say we take just zip code, right? Zip code, and that should have a size. Oh, give me a second. Just need to import the other request matcher. has size 2. So we just want to find two of the results here, right? Let me run this one. See if that works. Whoa, it's green. Awesome. So what happened here? I mean, this is just an arbitrary method that we just made up, and how does that actually work? So when the infrastructure actually finds the repository interface, it looks at all of the methods that are declared in it, and for some of the methods, like the ones declared in CRUD repository up here, we can basically resort to the predefined implementations, but for everything else, we just find the method and then apply a certain strategy to turn that method into a query execution. And unless you do anything further, we are going to try to interpret the method name as a query. So that thing here basically becomes select C from customer C, where c.address.zip code equals $1, right? So we can basically parse that into a property traversal and then make up the query here, and then on method execution actually execute the query, right? So we also support like keywords with like you could try like, or you could say contains or something. That's all in there. I think that should actually, yeah. You can use code completion and get the supported keywords if you're using STS. Get that. Also, what you also get is with STS is basically query method name validation in case you had a typo in there. Let me just try to re-kick that up. So the query method names are actually validated within the IDE for you. So if you try to run this thing with a broken query method name, the container would actually bark at you too. So there should be an exception saying there is no property address zip code for the type customer. So you don't get this thing to work or to bootstrap even with a misspelled query method here, right? So this is fine for simple cases and for like find by username and what have you. But of course, like in your real world application, you won't get that far with those simple queries. You might want to add some joins or have subselects in it, and you can do the workaround here is to basically manually define the query. So you can just like C from customer C. Let me just try that. If I just have this query here and execute it, our test should fail again, but it should fail with an assertion failure actually. Yep. Using name parameters. Okay, that's yep. Okay, that's good. Okay, it's trying to. Yeah, that's probably bullshit. And not trying to get this to work. It's complaining that we have a parameter, but don't refer to that in the query method. That's fine. I was just trying to get this query to fail because we were expecting two results, but now it should get 3, but it fails even earlier. So it detects that you basically misconfigured stuff here, right? That's kind of helpful. Yeah, that's basically the mechanism. So you have the declarative query methods in here. There is quite a lot of stuff that you can do with that. You can apply pagination. So you can go ahead and say, I have a pageable here which defines basically I want the first 10 results, or the first page by a page size of 10, and you get back a page that only has the slice of information, but also knows about the number of total pages, the number of total elements, and whatnot. So that's you get this out of the box. We support other return types, like you can take a stream here and will automatically get a Java 8 stream from the query method return, or you can just go ahead and use optional in case you have while a plain method that only returns a customer would return null, an optional would just give you optional empty here, right? That's basically it. There's more advanced features, so you can externalize the queries. You can use named queries for JPA. You can like selectively implement certain methods of that interface yourself. So while the method declaration or the declarative query mechanism might be sufficient for most of the queries, it might not be for some of the cases. There's means to do that. I don't want to get into the details of that one because I want to show you something different still. But there's like examples for that. So I had the custom implementations. I have query methods. There's also support to execute or build up dynamic predicates using a library called QueryDSL. So you can basically just define individual predicates like is long-term customer and is customer with or has spent more than $500 in the last month, and then combine them on the fly and easily do that. But I'd recommend to just look into the examples that we have for that kind of stuff. Right. So the bottom line here is you basically declare an interface, declare methods, and take it from there. Right. In the most simple case, it's just a method declaration. If it becomes more complicated, you move to just like declarative queries using @query or JPA named queries. And if it's becoming even more complicated, then you just go ahead and implement one single method yourself. Right. Do we have questions on that part of the story?
So we have, we've had a couple of questions in which Thomas is fielding. I'll mention one which is from Harmeet Singh, asking if it's possible to write native queries, which Thomas says yes, you can just use the annotation @query. Anything else you want to say about that, or is that pretty much?
Oh, there's a native query, and you say I think is it a boolean? I think it is. So there's just the value is basically the query, and you just like switch on native query support. That it basically just changes the way we interact with the entity manager. But yeah, native queries work here.
Okay, awesome. I think that's pretty much it. Meet MIIT was asking about performance optimization, but there's not too specific on that. So he just said, what about performance optimization and testing of this?
So I mean, hard to find a start point here. What I might want to add, because I showed you the pagination stuff, right? So pageable. For this to actually calculate the number of total pages available, we actually have to issue a second query, just a count query that finds out how many pages we have in total, and that might cause some performance problems, especially on other data stores like MongoDB or something. There you can tweak if you're not interested in that kind of metadata, you can like still restrict the result set and but return a list here that will basically not cause the second query to be triggered. There's also a slightly reduced variant of the page interface. It's called the slice, which doesn't trigger a total calculation basically, but only reads one more element than it's supposed to be. So if you're asking for 10 elements through that pageable here, we will actually be reading 11, and by the presence of the 11th element, we can basically reason about the fact that there is a next page, and basically can provide that information. Okay, there will be a next page. So it's basically to implement like a mechanism as you can see on Facebook, right? You read the first 20 entries of your timeline, and as you scroll down, you just realize, okay, there's more stuff to read, so I can find out about that and then trigger the next query. So that's the performance optimizations we apply. There's like a few things in here that that we use, especially for the streaming stuff, or for the stream APIs. We actually use the native JPA provider API, and to actually implement that in a real streaming fashion. So we cache the queries that are derived from the methods are cached. So the query object instances, criteria query object instances, are cached. So there's been quite a bit of effort into trying to optimize the heck out of that stuff. Of course, there is a certain overhead, because we have to analyze the stuff, but most of the really expensive stuff is done at startup, and after that's done, we have basically verified all the queries, we have built up the meta model and whatnot. So there shouldn't be a too big effort in at runtime, actually, or additional effort. Okay. I just go on, and then we maybe have a few more questions at the very end, because that's been the basics, fundamentally, how you work with that stuff. So creating interfaces and declare methods. I wanted to show you a bit more involved example that actually makes use of the Spring Data REST module. What we have in the examples is a showcase where I basically found a CSV file with close to 11,000 Starbucks shops in Northern America, alongside their geolocation data. And I thought, okay, that will make up a neat showcase for actually or showing people the geospatial functionality of MongoDB, and basically how you can actually expose that as a REST service. So basically, effectively, get a REST service where you can find Starbucks shops based on location, right? In Northern America, that is. So what I have here is I'm using MongoDB in this case, and I have a domain model here that's basically reflecting the data that we have in the CSV file. So we have stores that have a name. They're going to have an address. You see that it's also just basically MongoDB object to store mapping that's coming from Spring Data MongoDB. So indicating that this is an ID and this is a document, a MongoDB document. And we have a store and we have an address. There we go. And the address has a point, like a type point. This is a Spring Data type here, and that's capturing the location. And we're defining a geospatial index on it. That means that we instruct MongoDB to create an index on it, so that we can define geospatial queries on top of it. So it's these two classes, and you see that Lombok actually makes that quite easy to just implement them. There's a store repository that implements or extends paging and sorting repository, which is basically like CRUD repository, but with additional pagination and sorting in APIs. And then we go ahead and just declare that very method here. So right. So as you've seen that before, like find by address, location, and then there's a keyword near, right? So did you remember I mentioned that we want to have a programming model that has a certain kind of consistency, so works the same way, but still retains the source-specific capabilities. That's exactly where this comes through, right? So although we're on MongoDB, we still have the interfaces. We still use like the paging and sorting repository. We still use pages and just declare a method here. But we can now use a Mongo-specific keyword, which is near. That's not supported on JPA, of course, but on Mongo. And it basically derives, instead of deriving a JPA query, it derives a MongoDB query for it, and yeah, sets up a Neo query for that. And it binds a location parameter and a distance. And we also go ahead and use the pagination facilities that Spring Data has, and can go ahead and page through the stores. Because I mean, if we choose huge distances like 50 kilometers or something, then there probably might be like more than 100 stores or something, and we want to just like page through the result. So if I go ahead and just run the integration test for that, so I basically can write a test case that looks like this. What the application is doing, that's probably worth mentioning, is when I start it up, it checks or it imports the 11,000 Starbucks stores into the model. We can basically write this kind of code. So we say this is our location. I think this is like the pivotal New York City office or something. And we create a new store here for that matter. We create a new store, save that into the MongoDB, and then trigger the query and say, okay, we want find all the stores in exactly 1 kilometer's distance, and we want to have like the first page and with a maximum of 10 stores, right? And then assert that we basically find a single store that we've just created. Let me run this. It's starting boot. It's starting the repositories, and you see it just worked. It's the bar is green here. There should be, where is it? It's starting the, oh, that's the virtue of large font sizes. You don't find anything anymore. It starts some web stuff that we'll see in a bit, but it basically just like works. So it's just running the test, and that works. So we didn't actually have to like really code anything, right? So no query execution, no interaction with MongoDB ourselves. We just use it, and I mean that's the primary benefit we want to bring to the table, is that even if you've just been familiar with Spring Data JPA, you could just go ahead and see this project and roughly understand what it does, and maybe even add a second query method for that to work, right? What we're definitely not proposing is that you start thinking, oh, I can basically switch JPA for MongoDB or for Couchbase and what have you. That's definitely not the case, because these stores work differently. You still should have a decent understanding how the stores work, how you best map your data to the store, and so on. So it should be easy to basically switch from one project to another and find yourself familiar. But it's basically not advocating just exchange stuff, because that's not going to work. I mean, it can work to some degree, but it's not something that we actually recommend. Right? It's just you find yourself familiar, but are still able to hook into MongoDB details if necessary in a very convenient way. So we've just ran the integration test, so you see that basically works. Let me run the app as an app actually. So as you've probably seen some presentation of Josh or something. So this is basically a boot app, or how you start a boot app these days. You just run this thing. So I create run this as Java application. And I have deployed Spring Data REST with this project. So it's not only Spring Data MongoDB, but Spring Data REST. Let me check. There is Spring Boot Starter Data JPA. And yeah, in this case, I have the help browser module. I will get to that in a second. So it's basically Spring Data REST is on the class path, and by the virtues of boot is getting activated. So what does that actually achieve? Spring Data REST discovers all of the Spring Data repositories that you have in the class path or in your application, and if you're not like vetoing it, it exposes REST resources for that for this repository. So what I can now go ahead and do is basically use the JSON endpoint here that gets exposed, and what I get back is a let me just make that a bit larger just to make sure you all see that. What you get back is a document, which is a HAL document that is like an RC, so a JSON standard in this case, not a JSON standard. It's a standard how to represent links in JSON and hypermedia elements. But what this thing tells you is basically that there is a resource named stores, and that's available under that very URI, and you can actually pipe some parameters into that, right? So that's a so-called URI template taking some parameters, and I'm basically going to follow that link. So I just call that one without any parameters, and what I get back is the first 20 elements. Whoa, Jesus! I have to scroll up. So you see there are stores in here, and the stores have a name, and they have an address with a location, and it's basically listing the stores that are available in the database here. But it applies pagination to it by the virtue of the fact that we have the method, the repository actually implements paging and sorting repository. So you get a list of stores exposed to the web in a hypermedia-based way, so that you can then go ahead and say, okay, go ahead to the next page here, or I go to the last page, or there are searches even exposed. Let me try to follow that one. Stores search. So you see there's a by location search here, right? And then you say, okay, there's like this API store search, whatever the name of the URI is, that doesn't really matter. But it takes some arguments like a location and a distance and the pageable and all this kind of stuff here, right? Okay. So you can easily expose these methods. What Thomas has built on top of that is a tiny web API that just exposes. That's just a manually coded web UI using ThymeLeaf and the controller, but that tiny little GeoMaps or Google Maps JavaScript here is using the JavaScript API to actually call this resource here, get back the results, and then inspecting the results and putting these nice markers on that grid here. If I can go to, what is it, Times Square, New York, we had that. If I go to the pivotal San Francisco office, you see that are these markers here, and this is like all driven by the REST API we have just built with. I mean, let's be reminded, with an interface with a single method and 2 domain types consisting of 4 properties, and that basically being it, right? I think that's kind of neat. So that's basically it. So let me go back to the slides and finish that one off, and then I just have a couple of resources for you. So the project is at projects.string.io/stringdata. All the example projects, I can probably just quickly jump to them. Yeah, that's the. Let me go move that over here. It's on GitHub, and as you can see, it has samples for like JPA, MongoDB, the web-related stuff, Spring Data REST specifics, and whatever you want. So it's all listed here with all the contents, and we keep them up to date. We even sometimes have a sample put up there in a feature branch before we actually even get to implement the feature that the sample is supposed to showcase. But yeah, they are all up to date and if you want to play with those. Yeah, as you can see, Thomas just added support for completable future as return type for the repositories here. That's going to come in the next release. Where were we? Yeah, the examples. What I can also recommend is the Getting Started guides. If you just go to spring.io/guides. Oh Jesus, again. There is this page here, and you just type, let's say, you want to do something with JPA, and then you basically get a guided tour of building something very simple and very concise, and actually make you familiar with the technology at hand. If you want to just follow those along, it has very simple ones, but it also has like what is it? Hypermedia. Where is it? Yada yada yada. Hypermedia-driven REST web service. So it has a bit more advanced topics as well, like using that kind of stuff. All right. With that, I hope I didn't like stretch the boundaries too much.
No worries. That was awesome. I think we are on time and on schedule.
So yeah, I mean, if you want to get in touch or have further questions, ping me on Twitter, or I'll probably be around in the IRC channel for quite a bit. Whatever way suits you, open up for suggestions, for questions, for if you found bugs or something, just file a ticket, or yeah, happy about any input that you might have.
Sounds great. Thank you very much, Oliver. And if you could also send me those links, those 3 links on your previous resources slide, I'll add them onto the virtual jug page for the replay, and also we can add that onto the Rebel Labs write-up as well, so people can find the examples and where to go for more information.
Of course, of course.
Awesome. Yes. Let me put my camera back on. Actually. There we go. So yeah, awesome. I think we'll probably do questions in the IRC actually, because we're a little bit over, not too much. But what we can do is we're going to do an interview right after this with Oliver. So that's going to be cool. We'll put that up on the Rebel Labs website. For now, I'll just let me share my screen again. Also, it's quite funny that we're all wearing these funky X-Rebel shirts. If anyone does want one of these, I'll put a link into the IRC so you can do a quick download of X-Rebel and get one for free. Let me share my screen. Whoops. There we go. So yeah, thanks very much to Oliver for that session. The next session, we've got 2 coming up. One is on the 7th of July, and that's going to be the final VJUG Book Club session with Josh Block. I very much recommend that for those of you who have or haven't read the book. Actually, we do have some great discussions on that, and Josh is certainly a great person to ask general Java questions as well as specific ones about his book. So that's going to be happening on the 7th of July at 5 p.m. UK time again. And our next regular session is going to be on the 15th of July. I just put this up, or Shana just put this up for us on the Meetup site, so don't worry if you haven't seen it yet. It's literally only just gone up. And this is going to be a session from Christopher Beatty, who's actually who we saw at Geek Out Estonia and also DevOps Poland as well. So we've been spending a lot of time with Chris recently. And he's going to be giving a session called "So Why Would I Use a Distributed Database Like Apache Cassandra?" So there was a little bit of discussion about Cassandra in the IRC. So if you're interested in hearing more about Cassandra, do turn up on the 15th of July at 5 p.m. UK time. And let me go back to stop. There we go. So yeah, it just leaves me to say thank you, a huge thank you to yourself, Oliver, for another great session on the VJUG. And also, I'll say thank you. I'll say thank you as well to Thomas, actually, who's been in IRC who's been answering plenty of questions. So thanks Thomas as well. And if you'd like to hang on the line, Oliver, I'll stop the broadcast of this VJug and then we'll jump into an interview. So thanks everyone on the virtual jug for watching, and see you next time. Thank you.
Take care. Bye.
Bye bye.